Okay, so example 9, you could use a calculator or you just kind of have to think about it. So I know, easy to say that, but example 9, it says cosine theta minus sine of negative theta equals 0. Well, we definitely do not have like terms, but we can't use this identity because this is when things are squared. So I'm stuck a little bit. But there is one piece of information we have learned from Unit 5 that sine is known to be an odd function. What that means is when you input something that's negative, it negates your output. That's the definition of an odd function. So what I can do is I can rewrite this. Well, if I put in a negative, that means it's going to make this opposite. So I can get this. So you could think about, if you're looking at your unit circle, okay, what could I add together that would give me 0? Another way I could look at this is, well, what if I move that sign over? So just bear with me. I'm going to pull up this unit circle. Where does, on the unit circle, your cosine, so your x value, give out the same value for your y except y is negative? Okay, well, these are the same at pi over 4, but they're not opposite, so that doesn't work. But it does look like if I'm here, these give out the same values and they're opposites, right? So that would meet, that would work. Here, nope, because they're both negative, so that doesn't work. Let me put an X through here so you don't think it works. And then here, it would work, right? Because they would be opposite. So think about it. If you were to add this together with this, wouldn't you get out 0? If you were to add this together and this, wouldn't you get out 0? So that's why your solution is 3 pi over 4 and 7 pi over 4. Again, you can write it like that, or theta equals, or sorry, theta such that theta equals 3 pi over 4, 7 pi over 4. So sometimes, I mean, there's not a lot of algebra behind it, and you just kind of have to think about where you would be on the unit circle. Now for 10 and 11, we're going to rely on our calculators. So let's go ahead and get out Desmos. And that says sine of 2 theta, and I don't know what it said, equals cosine. Oops. Nope. Nope. Let's go back. Okay. Nope. There we go. Equals cosine. Whoa, that's intense. So what you have to do is you have to change your window. We only want it from 0 to 2 pi. Doesn't really matter our step. But some to get you in good habits, pi divided by 2 is a good step. And then if I'm looking here, I don't really see, oh, that's just going to give me the graph. I need to find the intersection. So I'm going to go ahead and say, let me get rid of here. I'm going to say this is y equals. And then my next one, I'm going to do y equals cosine, because then I can find their intersection. Okay, so let's change, make sure we just went from 0 to 2 pi. Okay, so our solutions are going to be this one, this one, this one, wherever that blue and red graph intersects. So it looks like we have 4. So our first one's pi over 6, then pi over 2, 5 pi over 6, 3 pi over 2. So going back here, we have pi over 6, pi over 2. I think it was 7 pi, but I'm not sure. There's 3 pi over 2, 5 pi. 5 pi over 6, and 3 pi over 2. So sometimes I'm going to have you just use your calculator. Because also, this one, I would be a little stuck, right? My period is pi for one, but it's 2 pi for the other. It'd be a little hard. Okay, let's actually do an application. A consumer notes the sinusoidal nature of her monthly power bills. In winter, when she uses electricity to heat her home, and in summer, when she cools her home, the bills are high. In spring and fall, significantly less electricity is used and the bills are much smaller. The following function models this behavior. Okay, C of t, that's your function notation, is the cost of your power bill, where your input t are months between 1 and 12, where t equaling 1 is January. I want to know when this function, when my cost, will be exactly $80. So I'm going to set my function equal to 80. Now let's just use some of our algebra skills, although I am going to let you use a calculator on this. Let me just ask you some things. What's your period? All right, well that would be 2 pi divided by that pi over 3. So I get 2 pi times 3 over pi. Pi is reduced out, so you get 6. So your period is 6. So that means you're having 2 cycles happen in the frame they want us to look in. All right, what's our midline? Looks like y equals 60, right? And our amplitude is 40. This is really important to ask yourself when you're relying on a calculator because it will help you figure out where you should move your window to be. So I'm going to go to here. I'm going to get rid of this. We want to know where it intersects 80. So I'm going to do y equals 80, not that, equals 80. And you can see you don't see it, right? But look, you're only going up to 15, so we're going to have to change that window at some point. Then my other function is 60 plus, oh geez, sorry, I'm moving too fast. Y equals 60 plus 40 cosine pi over 3, my input, minus pi over 3. And I'm just going to double check that because I'm going off memory. Yep, okay. I can't see anything here, so I'm going to go here. Remember, we went just from 1 to 12, right? They told us that in the problem, so I didn't even have to think about that. And how big I want this thing, well, think about it. If your midline is 60, you can go down 40 from 60, so the lowest would be 20, so let's just start from 10. And our highest, well, again, if I start at 60 and I go up 40, would be 100, so I'm going to do 115. Oh, you see this perfect graph. This right here is the hardest part, is figuring out your window. But just rely on information you already know to figure that out, like amplitude and midline. So it looks like her bill will be exactly $80, month 2, month 6, month 8. Let's see. You know, they did want us to include 12, so we should say month 12 as well. So 2, 6, 8, and 12. 2, 6, 8, and 12. So it looks like in months 2, that would be February. So let me just write this over here. 2, 6, 8, and 12. Okay, so we have January, February, March, April, May, June. July, August. And where was I? 8. So September, October, November, and December. Did I do that right? Yeah. Okay. Her monthly bills will be exactly $80. Okay, I'll see you in class. Oh, and let me just mention, in class, we're going to solve this by hand, so it'll work out more. Okay.